Simplify the rational expression and state the non-permissible values. Okay, so when we're trying to simplify a rational expression that is composed of monomial terms, like this one, I find it helpful to rewrite the expression as two fractions being multiplied together. Sometimes more fractions if you have more variables, but in this case we just have one variable, so two fractions will suffice. You can see that in the first fraction I have our constant coefficient terms, and then in the second fraction I have our variable terms. And that kind of lets us analyze the problem in two parts. So in our first fraction, we can simplify this by dividing both the numerator and denominator by 2. And then for the second fraction, we're going to have to use our exponent laws. Remember that one of the exponent laws tells us that when we have division in this form, we can simplify it like so. So basically, we take the exponent in the numerator and subtract the exponent in the denominator while keeping the same base. So 94 divided by 2 is 47, 6 divided by 2 is 3, and that'll be times x to the power of 2 minus 3. We have 47 thirds times x to the power of minus 1. Remember that a negative power just means that the variable, or whatever number is being raised to that negative power, is raised to that power in the denominator. So basically the negative power simply means put the variable or the term in the denominator and keep that same absolute value of exponent. So it'll look something like this. We have x to the positive 1 now since it's in the denominator. However, we don't really need to write that positive 1 because it is implied. So this is the simplest form of our rational expression, 47 over 3x. Now, the non-permissible values are going to come from the original expression, this one here. However, they are the same for both expressions. So in this case, it's not super important that you analyze the original expression. However, in other cases, it definitely will be important that you don't get your non-permissible values only from the simplified expression. So in this case, remember, we're looking for the values of x that will give a 0 in the denominator. So we're looking for values of x that make this equation true. So we can solve for those values by isolating this equation for x. So we'll have that x cubed is equal to 0, that x is then the cube root of 0, and that'll basically just tell us that the x value 0 will give a 0 in the denominator. So our non-permissible value, and I say value because there's only one in this case, is 0. Okay, so these two statements combine to make the solution to this problem. Thanks for watching, and I hope this video helped you understand the problem a little better.